This solar-powered airship, named Solar Airship 1, is set to embark on a 20-day journey around the world without stopping for fuel, marking a significant stride towards sustainable aviation. The 495-feet-long airship, enveloped in solar film, will harness solar energy to power its electric propulsion systems during the day and utilize hydrogen produced from electrolyzing water to keep flying through the night. With a mission to complete a zero-emissions circumnavigation along the equator, covering approximately 25,000 miles in 20 days, it aims to showcase the potential of zero-emissions long-distance aviation. Despite an average speed of just over 52 miles per hour, this airship can halt and commence flight almost anywhere, eliminating the need for a runway. Piloted by a trio of adventurers including a former astronaut, a paraplegic pilot, and a serial adventurer, the airship is anticipated to take to the skies in 2026. Beyond mere transportation, the project symbolizes a key step towards addressing the aviation industry's carbon emissions challenge. The history of airships dates back to the 19th century, with the concept evolving over time. Initially, airships were seen as a promising mode of transport. The first successful airship flight was carried out by Henri Giffard in 1852, powered by a steam engine. Later advancements led to the use of hydrogen for lift, and Ferdinand von Zeppelin played a crucial role in popularizing rigid airships, known as Zeppelins, in the early 20th century. Scientists have created artificial photosynthesis that doesn't need sunlight. Photosynthesis has evolved in plants for millions of years. This natural process turns water, carbon dioxide, and the energy from sunlight into plant biomass and the foods we eat. This process, however, is very inefficient. Only about 1% of the energy found in sunlight ends up in the plant. Scientists found a way to bypass the need for biological photosynthesis altogether and create food independent of sunlight by using artificial photosynthesis. By liberating agriculture from complete dependence on the sun, artificial photosynthesis opens the door to countless possibilities for growing food under the increasingly difficult conditions imposed by anthropogenic climate change. Drought, floods, and reduced land availability would be less of a threat to global food security. Crops could also be grown in cities and even provide food for future space explorers. Artificial photosynthesis offers innovative applications across varied industries, including the production of biofuels and bioplastics in bioengineering and generating essential chemicals in a sustainable manner for chemical production. In healthcare, the technology can be utilized to manufacture drugs or bioactive compounds, while in waste management, it has the potential to transform organic waste into valuable energy or products. Japan successfully tested a system that harnesses the energy in deep ocean currents. A Japanese company developed a turbine that converts subsea currents into a steady source of electricity. The company wants to harness the power of the Kuroshio current. The Japanese current is one of the world's strongest currents. The giant machine is equipped with two counter-rotating turbine fans. Engineers called the 330-ton prototype Kairyu. It is designed to be submerged at a depth of 30 to 50 meters. The generated power is then transmitted via seabed cables. The prototype has successfully completed a major field test in the waters off Japan's southwestern coast. The prototype automatically adjusts its orientation to find the best position to generate power. The turbine's blades rotate in an opposing direction, keeping the device relatively stable. The push of the deep water current is then channeled into a grid. The prototype generated a total of 100 kilowatts of power in a flow of 1 to 2 meters per second. Japan is the world's fifth largest oil importer, but it hopes to make renewables the main power source in 2050. Renewables account for 24% of the energy mix in 2020. Oil product consumption has been generally decreasing steadily since 1996, but oil demand from power plants increased by 80% to compensate for the closure of nuclear plants. All of Japan's nuclear plants were closed after the 2011 disaster.